En de vrijwilligers die staan achter een toog zelfs.
Ja, oké. Die zijn er al die foto's al aan het klaarmaken.
Oké, alright.
Dus, veel plezier.
Alright, dankjewel. Ja. We're also live streaming to YouTube now. But you're not in the picture, so the camera is pointed that way, so don't worry. But careful what you say, it might be on YouTube tomorrow. Yeah. Hello, yeah. People on YouTube, do you hear us? You should hear us now. So if you hear us, put it in the chat, and then I hope you can follow along. Yeah. Hello? Is this microphone working? No, not at all. Huh? No, it's not doing anything. Damn it. Still a little bit? You hear something through the microphone. Okay, good. Yay. People online can hear us as well, so it's good. Welcome. Hey guys. Oh. All right, the first speaker is up in 5 minutes or so. You guys can still hear me through the microphone, right? Or do I need to shout louder? No, it's good, right? Yeah. We're still missing one speaker, actually. Steve from OHL himself, like not Steve Latre, but the other Steve. Is he in the room? No, huh? No. But he's from OHL, so he should be in the building at least. I hope he shows up. But the other speakers are here, and they tested their laptops, so it should be working. Maybe I'll already give a quick introduction of the talks we're having tonight. So it's a bit of a special meetup tonight. It's all related to sports. That's also why we wanted to host it in OHL. So thanks again to OHL for allowing us to get this room for free. By the way, if you look on the website, it's quite expensive to get this room, but we got it for free. So thank you very much, OHL, to be so kind. And you can repay them the favor by drinking lots of drinks after the talk. That's not for free. But it was very nice to have this room. Also because I think most of you know, normally we're at Stuk in Leuven. And Stuk, they were so smart after 1.5 years of pandemic, when everything opened up again, they decided to redecorate the place. So now they're closing down again for the rest of the season. So we have to look for other places until they're back. As I said earlier, we're not sure what to do yet with December. If we should do it again physically or switch back to virtual, we'll have a discussion somewhere next week or something to see what we do. I hope we can still keep doing it like physical meetups. That's what I like the best as well. I like to see people. Like, big part for me for doing Data Science Leuven is, well, the talks are nice, but I'm mainly there for just to meet people and talk with people. And you can do that a lot less on YouTube. So by the way, hi YouTube. It's nice that you follow along, but you only get half of the experience, unfortunately. As I said before, like, we're all here with a Corona safe ticket. We're all here wearing masks. If you're seated, the chairs are quite far from each other. So if you feel comfortable just, well, taking your mask off while you're seated, that's fine. If you start running around again, it's better to put your mask on. Also for the speakers, if you're here by yourself, so you can also take the mask off, right? But then if you go back, yeah, we just try to follow procedure as much as we can. The 4 speakers I have for you tonight, you've seen them on the meetup page, but we'll begin with Pieter Robberechts from KU Leuven. He's sitting right there. He will talk about finding the next Messi. He will bring that message here at OHL, so maybe they can do something with it. Not saying they need it, but. Then Steve Probst from OHL will give a talk himself. He leads performance and health here, and he's going to show basically how they use data from when a player is onboarded to the team to when they play the match, like the entire life cycle, actually what they do, how they use data to improve the performance of their players. So it's very nice that it doesn't always have to be like this abstract Netflix thing or whatever. It's happening right here, like to improve these players' performance. Next is Steve Latre. Yeah, there's Steve. Hi. From, I didn't know what to say. Should I say you're from IMEC or from UAntwerp or from IDLab? Or like you have so many. Yeah, you get paid 5 times, I think. Yeah. Anyway, Steven is a professor and he's going to talk about AI and cycling. So from improved storytelling to improved athletes. Steven is also, I'm right, I hope, you're the guy behind like Wie wint de koers.be, right? So he predicts who will win the next cycling race. I hope you're going to share some things about that as well. And then finally we have Agata Bak-Geerinck. Agata is there. Hi, from. No, welcome, Agata. It's very nice for you to be here tonight. You're going to talk about not only football fans, what do we learn about Belgian football lovers from TV viewing data? So a bit more of a, let's say, not in the middle of the action, but what can we see from, what can we learn from the fans based on the data that they see on the TV viewing behavior? So it's a quite packed evening. Normally I have 3 speakers, but now we couldn't say no, so we had 4. So I proposed let's get started. We still aim to finish around 9. Let's see, we have about 20 minutes per speaker and then some follow-up questions. So I'll try to time box it as best as I can. With that being said, let's dive in. The first speaker is Pieter Robberechts. Pieter, welcome. I'll also give you the HDMI.
Thank you.
Yeah. Oh. That should work, right? It worked before, so.
Just do it again.
Ah, yeah, it's not in. Sorry, it's my mistake. Yeah. Yeah. Yeah.
Yeah, now it's inverted. All right, I think it works. So before I start, I would just like to mention that a lot of the work that I'll present today was in collaboration with my colleagues Jesse Davies, Tom de Kroot, Lotte Branse, and Jan van Haren. Right. If you follow Belgian soccer, you probably know that something quite unique has been going on at the top of the table, because the team that's currently ranked first, Union Saint-Gilloise, that's a team that actually promoted only last season from 2nd division, and they are actually the team with the smallest budget in the entire league. So how is it possible that a team like Union is currently the best team in Belgium in a sport that's usually dominated by the rich guys? Well, at least part of the answer might be Moneyball, which refers to the use of data in sports and especially in recruitment. The origin of the term Moneyball is actually in baseball, where the Oakland Athletics team in 2002 realized that they had to start to do things differently if they wanted to make a good season. And their idea was to start recruiting players based on data and statistics to take the gut instinct and the emotion out of the decisions that are involved in recruiting players. And it immediately paid off because next season they won their league with a win streak of 20 games. And there's actually a Hollywood movie about this, and it's generally seen as a start of sports analytics. Now, the story of Union is actually quite similar. Before the Second World War, they were the most successful team in Belgium, but they spent the past 48 years outside of Belgium's top division. And that started to change in 2018 when they were acquired by Tony Bloom. He's also the owner of Brighton in the Premier League, but more importantly, he's the owner of Star Lizard, which is a company that sells soccer match data to professional gamblers. And he's also well known for deploying this data for recruiting players at his clubs. So at Union, they started to do this as well. They started to recruit players from the third German division, the third French division, from Denmark. And this quote is by their CEO. He mentioned it last summer in a podcast. So he said, "We have a lot of data. That is how it all starts. It brings us to places where other teams do not come." So Union started to recruit players based on data. And as it did for the Oakland Athletics, it immediately started to pay off because like one season after they were acquired by Tony Bloom, they made it to the semifinals of the Cup of Belgium, which is quite unique for a team in the second division. And they also started doing very well in the second half of the season in the competition. Then the next season you can forget because of Corona, but then last season they promoted to the first division and now they are basically the best team in Belgium. So this is probably the first success story of the Moneyball approach in Belgium, but there are many other success stories abroad. The most well-known ones are FC Midtjylland in Denmark and in the Premier League, Brentford and Liverpool. But actually, I think these days, virtually all teams are using data during the recruitment in some way at least. What teams have realized now is that insights from data can help them in two ways. First, it can help them because like there are way too many soccer players in the world to scout them all, and data can help them to create a short list of interesting players. But actually, these days, data is used in every step of the recruitment process just to validate the insights of scouts. So these days, we use data to answer a multitude of questions, and it would take me a bit too far to answer how we use AI to answer all these questions. So I'll focus on the last two ones, which is how valuable are the players' actions? So how can we use AI to measure the contribution of a player, how good a player is? And second, how does the player cope with mental pressure? The kind of data we use to answer these questions is called event stream data, and this data describes all on-the-ball actions that happen during a soccer game. Maybe you remember the goal of Kevin De Bruyne against Brazil in the previous World Cup, and this image shows the sequence of actions that led up to this goal. So maybe as you remember, it started with a corner kick by Neymar. Then Fellaini clears the ball. It is picked up by Lukaku. Lukaku runs to the other half of the pitch where Paulinho tries to stop him. But he still manages to pass the ball to De Bruyne, and then De Bruyne shoots some goal and scores. So for each of these actions, they are annotated with a couple of fields, like the type of the action, the player that executed the action, the team in possession, the result of the action, the body part used, the time when the action was executed, and the coordinates on the pitch. So this event stream data describes all on the ball actions, but it's actually getting more and more information rich. Like in the most modern versions of this data, you also have some off-the-ball information, like when a player shoots some goal, you also have the location of all other players on the pitch. But most importantly for scouting players is that this data is widely available for hundreds of competitions, even for lower level leagues. And that is because this data is collected manually by human annotators who just like watch broadcast video and then write down everything that happens on the ball. So you can basically get this data for all matches that are filmed. Now, how can we use this data to assess the performances of soccer players? But maybe I should start by explaining what's wrong with the traditional statistics that are used in soccer. I think there are two problems, and the first one is that they are focused on a limited number of actions. If you think about statistics used in soccer, you probably think about goals, assists, and shots on or off target, which are all related to shots. But the problem with shots is that they constitute less than 1% of all on-the-ball actions that happen during a game. So this image here, each square represents one on-the-ball action during a game between Man City and Wolverhampton. And with the traditional shot-based statistics, we can only say something about the green squares. But ideally, we would like to say something about all these squares. And I have to admit that there are some statistics that can say something about the gray squares. For example, for passes, we have the pass success percentage, which represents the percentage of passes of a player that successfully reached a teammate. But the problem with these kind of statistics is that they value all actions of the same type equivalently. So what I show here is the 5 players with the highest pass success percentage in the previous season of the Premier League. And what you notice is that these are all central defenders, while a player like Kevin De Bruyne, who is generally known for his good passing skills, is only at spot 134. So that can be explained because these central defenders can give a lot of these easy passes between each other, which don't really add something to the game. And I think this clip is a good illustration of what's wrong with the current statistics. So it starts with a very easy pass by Stones to Laporte. And then Laporte gives this amazing through ball to Sané. Sané gives the assist and Jesus scores the goal. So with the traditional statistics, all the credit for this goal would go to Jesus for the goal and Sané for the assist, while Laporte, who gave that amazing pass, will get exactly the same amount of credit as Stones, who gave that very easy pass. So ideally, what we want is to assign a value to each of these actions, which measures how much each player contributed to scoring that goal. So how valuable is an action? Our intuition was that an action is good if it increases the short-term probability of scoring or it decreases the short-term probability of conceding. And that's clearly the case for this pass by Laporte. So hence, a natural way to determine the value of an action is to measure the change in value between the pre-action and the post-action game state. And therefore, it's important to understand what I mean by this pre-action and post-action game state. So the pre-action game state, that's the moment in the game when Laporte receives the ball. And then you have the pass or the action, which moves the game state to the post-action game state. And that's the moment in the game when Sané has the ball. So our idea now is to not assign a value directly to the action, but instead we assign a value to both game states. And I just mentioned that value is the probability of scoring or conceding. So for example, for the pre-action game state, the probability to score a goal there is 1%, and the probability to concede a goal is 2%. For the post-action game state, it's 23% and 1%. And then to assign a value to the action, we compute the difference between those probabilities. So the increase in the probability of scoring is 22%, and the decrease in the probability of conceding is 1%. Then we just add these up, and that gives us a value for the action that's 0.23. So I don't know whether you've noticed what we're doing here, but actually what we did is we've transformed the subjective task of valuing actions to the objective AI task of estimating probabilities. So what we're doing here is we're valuing actions by estimating probabilities, or we're vaping. And vape, that's the name of our framework. So this formula just expresses what I just explained. So we compute the vape value of an action as the change in the probability of scoring or conceding between the post-action and the pre-action game state. The only thing we still have to do is compute the probability that a team will score in a particular game state. So I hope you remember that event stream data represents a soccer match as a sequence of on-the-ball actions. Here, the most relevant actions, which I showed in the clip, are the pass by Stones, the pass by Laporte, then the assist by Sané, and the goal by Jesus. Then we want to assign a value to the pass by Laporte. And remember that the pre-action game state is everything here that happened before that pass. Obviously, what happened 10 minutes ago isn't relevant anymore now. So we represent the pre-action game state by the 3 actions that happened before the pass. and then we shifted by 1 for the post-action game state. Then the next step is to transform this game state representation into a set of features. For each of these actions, we compute features like the start and end location of the action, the type of event, the body part used, and some features that combine these 3 actions, like the speed of play, which captures whether it was a counter-attack or a slow build-up. And we also add some contextual information, like the time in the game and the current score line. And then as the label, we use whether a goal is scored within 10 actions after the game state. Next, we collect a bunch of these game states, and we start training a probabilistic classifier, which tries to predict whether a game will be scored soon after that game state. Once we have that classifier, we can use it to compute the values or the probabilities for unseen game states. All right, let's go back to the start and see whether we've solved our problems. So, as I said, the problem with the traditional statistics is that they focus on a limited number of actions, but with FAPE, because we can assign a value to all actions in a game. And the second problem was that all actions of the same type are valued equivalently, but FAPE takes into account the context of an action. And now you see that the best passers in the previous Premier League season are first Jack Grealish and on second spot Kevin De Bruyne. So it seems that our approach does a much better job than the existing statistics. Now, the most important application of FAPE is rating players. Here in this graph, each point represents 1 player. The x-axis is the actions per 90 minutes or actions per game that a player performs. The y-axis is the average action value of a player's actions. What you see there, there's a clear trade-off between the number of actions that a player performs, so the quantity and the quality. So to rate players, we compute the average FAPE value per 90 minutes, which takes into account this trade-off between the quality and the quantity. Then in 2018, when we published this FAPE approach, we computed the FAPE rating for the under 21 players in the Dutch league. And these are the 5 players that had the highest FAPE rating back then. Now, if you look at where they are today, they are all at top clubs in England or Spain, except maybe for David Neres. But you can also see that their transfer value skyrocketed. Like Frenkie de Jong was 7 million worth in 2018. Now he's 90 million. So it seemed that our FAPE approach did a good job there. Now, what most people are actually interested in is this question: who is best, Ronaldo or Messi? Well, according to FAPE, Ronaldo here in blue is quite good. He's actually season after season one of the best players in Europe. But Messi is just in his own league. He's like ways apart from everyone else. Then in the second part of my talk, I would like to explain how you can use data in soccer to measure how players perform under mental pressure. But first, to motivate why that is important, I would like to go back to one of the most iconic moments in recent Premier League history. It's the last match day of the 2012 season, and City and United are tied for first place, but City leads on goal difference. In the meantime, Manchester United has just beaten Sunderland, which means that Man City has to win to get the title. But currently, with only 3 minutes left on the clock, it's 2-2. So City has to score. And I guess that most people already know what has happened, but let's watch anyway because it's fun.
Manchester United's game is over. So is Bolton's game at Stoke. QPR are safe. They don't know it yet. Latre. Aguero! Staggering!
So I don't know whether you've noticed it, but there's actually only one player here who dares to ask the ball. That's Aguero, and then he even makes the goal himself. So these are the kind of players that you need in your team if you want to decide a game in the crucial moments. Players that are not affected by stress and it can decide a game where it matters most. This slide gives a high-level overview of our approach. So given a specific action, like a dribble of Messi into the penalty box, we first try to assess how well the player executed that action. And then we try to assess whether the player executed that action under a high or a low mental pressure. If you have these two components, we can compare the performances of a specific player under high and low pressure situations by aggregating over many actions. So the first thing we need is a way to assess the performance of a player. Therefore, we can use our contribution rating, which is the VAPE rating that I just explained, which measures how an action changes the chances of scoring and conceding a goal. But our hypothesis was that mental pressure might affect the player's performance in different ways. It might affect his decision-making skills, or it might affect his execution. So we designed two new metrics: a decision rating, which measures whether the player selected the best possible action, and an execution rating, which measures how well the player performed that chosen action. These two ratings are actually quite similar to our VAPE contribution rating, so I'm going to skip over the details because I want to spend some more time on how we assess whether a player executes an action under high or low mental pressure. So here our hypothesis, hypothesis was that mental pressure is affected by two dominant factors. First, you have the pre-game context, which is set before the start of the game. And that involves the location where the game is played. So is it a home game or away game, the opponent, and the momentum. The second factor is the in-game context, which can change during the game. And then we just multiply these two to get the total pressure that a player is exposed to. Now, first, to assess pre-game pressure, that's challenging because there's no ground truth here. And even for people, it's quite hard to assess under which mental pressure level a team is playing. For example, for the game of last weekend between Belgium and Estonia, if I would ask you to rate the mental pressure that Belgium was exposed to in that game on a scale from 0 to 5, for example, I think you would find that quite challenging. Our insight was that it's much easier to compare two teams. So then the question becomes, which team experienced most mental pressure? Was it Belgium or was it Wales? And then I would say Wales, because Wales really had to win that game to still have a chance to qualify for the World Cup. So our solution is to treat this as a ranking problem. And we first asked a bunch of soccer experts to rank pairs of games. So we gave them a pair of two games and we asked them which team here experiences most mental pressure. We also gave them some context, like the current league table, recent results, and some facts about the game. Then we trained a gradient-boosted tree ranking model, and we represented each game by a set of 13 features, which describe the game context, the recent performance of that team, the ambition of that team, and how important that game is for the team to reach that ambition. And then this figure illustrates the pre-game performance during the 2017-2018 season for Everton. Here in the first row, you can see the position of Everton in the ranking. Then the row below shows their result during the game, so a win, a draw, or a loss. And here at the bottom, you can see the pre-game mental pressure for Everton. And what you see is that at the start of the season, the mental pressure is quite low, but then it increases and they start losing games. And it's very high here when they just fire their manager and when they end up at the relegation spot. Then it starts to decrease again when they win games. Then, here you have very high pressure because they changed manager again and they had the derby against Liverpool. And then at the end of the season, you can see it's again quite low because they're safe from the relegation spots and they can't qualify for Europe anymore. So it doesn't really matter anymore whether they win or lose their games. Now, the next part is to assess the in-game pressure. And there, our intuition was that in-game pressure is tied to goal difference. So imagine it's 5-1 at the end of a game, then it's nearly impossible to still change the win or loss outcome of the game. So we think that the pressure is quite low in such a game. On the other hand, in the game between City and QPR, it was a draw near the end. So scoring there would have definitely changed the outcome of the game. So there the pressure was high. Hence, our solution was to look at the potential change in win probabilities at each game state. And computing win probability, that's again a machine learning task. I think you will start to seeing a pattern here. We're just all the time translating practical problems into machine learning problems. So estimating win probabilities, what do you have to do? You have a game state, so you're at a particular time in the game, and you try to estimate the probability that the home team will win the game, that the game will end in a tie, or that the away team will win the game. Hence, this is a probabilistic classification problem. Now here again, you see the win probabilities for Everton here. At the start of the game against Watford, their win probability is about 50%, but then it decreases when Watford scores a goal, and it decreases further when they score a second goal, and it starts to increase again when Everton starts scoring. So then you can transform this into the in-game pressure, which is the change in win probability when a team would score a goal, and you see that it's here highest near the end of the game when the score is tied, and it decreases again when Everton wins the game. So now we have everything in place to start assessing how players perform under high mental pressure situations. And what we found is that Neymar chokes under pressure. Maybe not a surprise for many of you. So this graph here, the curve shows the average contribution rating, so the average VAPE value for all forward players in the top 5 leagues in Europe. The blue shows it with low pressure. The orange one shows it with high pressure, and the dot represents Neymar. So when the pressure is low, Neymar is among the better forwards, but when the pressure gets higher, he's only an average player. And what we found is that this drop in performance can mainly be explained by a drop in his decision-making abilities. So here, when the pressure is high, he performs fewer actions with a high rating, which are of the type crosses and dribbles. So he's basically getting more egoistic when the pressure gets higher. And that more or less rounds up my talk. So what do you have to remember? First, I've explained that data-driven scouting is now a standard practice in soccer, and it's mainly based on event stream data. Then I've showed how our VAPE framework can be used to measure the contribution of players for a wide range of actions, and it takes into account the action's context. And finally, I've shown how we can capture mental pressure as a combination of pre-game and in-game context. I've had to skip over a lot of details, so if you're curious and want to learn a bit more, the VAPE framework is explained in this first paper. In this paper, we explain the mental pressure approach, and our VAPE framework is also open source, so you can try it yourself if you want. And finally, we also maintain a blog in which we describe our research in layman's terms. And that's it. I would be happy to answer any remaining questions.
Right, so it's question time, but before we come to that, I appreciate the fact that you were explaining the importance of pressure in sports, especially given the fact that we are here in the Panenka room.
Here in the corner room.
Sorry about that. Well, there we go. In any case, we only have one microphone, so I propose that if you have a question, that you speak out loud. And then I'll ask you to repeat it so that on YouTube they can follow, okay? So who has a question? Otherwise, I have a very boring question about the psychometrics, and you don't want that. So, come on, get the questions.
There were some questions on YouTube as well, but yeah.
Okay, this gentleman here. Yeah, go ahead.
I just wanted to ask for the VAPE values, is the context of the game also taken in account? Because that pass from Laporte, if they are, for example, winning, it's not as good of a pass. If they are losing, or if they want to score, or if they want to.
Yeah, so the question was whether in the VAPE ratings we also take the context of the game into account, like the current scoreline, and the answer is yes, we do. So in VAPE we also take into account the current scoreline and the time remaining in the game, and that actually affects the probability of scoring, because like near the end of the game, at least that's our hypothesis, players tend to get a bit more tired, so it's usually a bit easier to score near the end of the game, and that's how it affects the VAPE ratings.
And also, is the mental pressure, does it act like a multiplier for the VAPE value, or can it also be used there?
So the second question was whether we use the mental pressure as a modifier for the VAPE values. No, not really. We compute them apart from each other. So we have the VAPE values, which measure how much a player contributes to the game with his actions, and we have the mental pressure. that just linked to an action, and it classifies an action as executed under high and under low mental pressure. And then we just like look at all the vape values for the actions that were classified as low pressure and high pressure separately from each other.
Okay, someone else I saw. Okay, this gentleman there, yeah.
Are the pressure scores the same for every player in the team?
So question is whether the pressure scores are the same for every player in the team, and yeah, there the answer is yes, because we compute mental pressure at the team level. And maybe that's not like entirely correct, because I guess like when a team is behind, that the pressure is higher for the attacking players because they are the ones that have to score the goal, and the defenders can sit back a bit more, especially when a team is really pressing the other team and is dominating. So we made a simplifying assumption there.
So maybe when it's your first match or something like that, the pressure can be higher.
If you're normally on the bench, like for a couple of weeks, and
Mhm.
the first time you
Yeah.
started, then the pressure for that individual will be higher.
Yeah, indeed. So just repeat it. So if a player is on the bench and he gets his first chance in the team, then he'll probably have a higher mental pressure, and I agree with it. But yeah, we had to make some simplifying assumptions to keep it doable.
There was one more question from YouTube. I propose after that, well, maybe you can ask your question at the bar, because we don't have a lot of time. So there was one question from YouTube asking about, is the data that you use, is it publicly available, or is it like behind paywalls? So how does it work?
Yeah, so there are small amounts of data publicly available, but it's rapidly increasing. So if you Google for StatsBomb open data, you will find a bunch of open data. What we did is we just scrape data, such that we can get data for like, multiple seasons.
Okay, cool. All right. Yeah, I know there's some people who still have questions, but since we have 4 speakers tonight instead of 3, I propose just try to hunt them down at the bar. Thank you again, Pieter. And
Ja.
Dank u. Hi Steven. Wil je ook deze microfoontje aandoen als we naar YouTube te streamen? Dus je hebt er 2.
Ja, dat is
ja?
goed.
Super, dank u. Ze weten hoe dat hier werkt, hè? Beter dan ik misschien.
Ja.
Dus,
Kunnen we ik toon wat persoonlijke data ook, dat daarna niet op YouTube, is dat oké?
Sorry?
Dat we het nu wel live streamen,
Ja.
maar daarna dat we het niet houden daar.
Hoe bedoel je houden?
Ja, dat je het niet binnen 20 weken nog kunt zien.
U wilde dat is dat wel gevoelige data dat
Ja,
erop staat?
ja.
Oké, ja, ik zal...
Maar je mag ze maar
Nee, is goed. Ja, maar dat is goed dat je het zegt. Dan, dan zal ik na een week of zo eraf halen.
Ja, voilà.
Of die gevoelige dingen wat blurren of zo.
Ja.
Ik zal wel zien. Ja. So while Steven is preparing his laptop, this is Steven Probst. He's playing a home game from OHL. He's head of performance and health, and he's going to talk about how OHL uses data to improve player performance. If the screen stabilizes, I guess Steven, also the people on YouTube asked if you can stand somewhere in this area, so you're somewhere on the YouTube screen. So.
Ja, dat is te laat.
It's getting there.
Boompakken ook.
Ja.
Precies, dat zit niet.
Hier is, ja, precies. Thanks. Ja, sorry, het is een beetje veel kabeltjes.
Pas op.
Okay, microphone. Good afternoon, everyone, or good evening. I'm going to be the odd duck a bit today. I'm not going to talk about football. If you're here in this nice venue, you could forget that there is another very important sport in Belgium, and that's cycling. So I'm going to talk about cycling, but before I do that, I'll maybe answer the question that Chris had. Are you now University of Antwerp or IMEC or IDLab? Well, it's even worse. I'm also Ghent University to some extent. So I'm actually part of IDLab. I'm leading the Antwerp side of IDLab. And we're a research group that consists of both University of Ghent, both University of Antwerp, and we're part of IMEC as well. And we're doing two main things. We're working on wireless networking. That has little to do with today, but we're also working a lot on machine learning, and that's why we're here. We're mainly looking at a lot of applied projects where we're trying to translate what we have in terms of machine learning to very specific sectors. Amongst those is also the sports sector, where we're working together with a lot of sports-related companies, teams as well. We're hoping actually that by tomorrow we can add OHL as well, because we're also coordinating the project that Steven talked about, that we will know about tomorrow. But so what I will talk about is cycling. We have already heard a few very nice stories today about how in football machine learning and AI can really drive innovations. I think there are already a lot of companies that, as Steven showed, as Pieter showed as well, a lot of companies that already are doing a lot right now in terms of machine learning there. In cycling, I think they're a little bit behind to some extent. And I think if the innovation can come from somewhere, it's going to come from these areas, Belgium, Netherlands, and so on, because we are for sure one of the only ones who are, maybe next to Colombia, so cycling crazy at all. And that innovation in terms of improving how cycling works can actually come from several ways. You can look at it from a performance perspective. We could also look at it from the way we perceive and how we watch and enjoy cycling. If you look at how we actually do this over the last few years, it hasn't changed that much. This is an image or video footage of in 1986. Some of you might have remembered this. This is Adrie van der Poel, who's winning the Ronde van Vlaanderen, Tour of Flanders, against Sean Kelly. This is about 34 years later, more or less exactly the same. Well, it's exactly the same in the sense that it's again a Van der Poel who's winning. One of the most beautiful most beautiful sprints I've seen, actually, or most intense games I've seen over the last few years. But if you look at the footage, nothing has changed that much. Okay, we have HD right now, and that's for sure much better. But in reality, the way we perceive cycling is just exactly the same right now. And still, there's a lot you can do, because actually all this data, there is a lot of data. There is data in terms of the video footage itself, but also the riders are just a swarm of moving sensor data as well that you can interpret from a performance perspective, which can for sure also interpret that to improve storytelling. And so that's exactly what we're doing. We started off actually in trying to improve the storytelling of it all. So starting to improve how you can, as a spectator, enjoy cycling in a more data-rich way. The last few years, we've moved on a little bit to also look at the performance side as well. And so my talk of today is going to focus on these two parts. How can we improve data? How can we improve cycling by data for an improved storytelling, but also for an improved athlete later on? So starting off with storytelling. What do we do there? Well, we have a lot of pipelines where we apply basic machine learning models, basic computer vision models, to really detect what's happening in the race. A cycling race is pretty complex, especially if you look, for example, at cyclocross. It's pretty complex in terms of what can happen and how it all evolves. And what we did in the last few years is built together with people also from Ghent University, built an entire pipeline that can actually detect exactly who is doing what at which moment in time and how does that evolve. It actually got a little bit of international press as well. I'm not sure if people know GCN. It's a part of Eurosports. They showcased the research we had there, and called it probably one of the most ridiculous innovations they've ever seen in sports. But still, we're very proud that we actually managed to get into that GCN podcast. We combine that with what we call a personalized suffer score. So we take into account the heart rate values from the different riders. We got access to these during the race. And based on their own personalized heart rate model, we tried to predict somehow a heart rate suffer score. All with the goal that you could actually build dashboards out of this. And this is a dashboard of one of the cyclocross races. We actually show you how a race evolves and how every individual rider is suffering from that. This is at this moment in time not being used for performance perspective because it's not data rich enough. I'm going to come to that later on to really make specific decisions. But there is a lot already you can do from a storytelling perspective as well, because you can really visualize during the race how hard is Wout van Aert suffering at this moment in time. Maybe he's in front, but maybe he's taking it a bit easier. Well, these are all things you can really visualize. If you have these two components, if you know how hard every rider is suffering, and if at the same time you also know exactly what is happening, you can actually do something very in all of that. And we did that together with Sportza. So right now they have an entire dashboard system now called Second Stream, where fans can, for specific cycling races, pop up this second stream. And it's a very data-intensive dashboarding of what's happening during the race. It contains our suffer scores. It contains what's actually happening during the race, and it also contains a lot of detailed information about what's happening, purely text based. And if you think that a human is just texting or is just writing all this text, well, guess again. In reality, it's our AI system that is actually doing all of this. So what we're doing out of these video footage, we're generating specific segments, or we're detecting specific segments, and we're then generating texts that the sports editors could actually use per rider. And for them, it's only a matter then of selecting the most important ones. We're generating more than they will actually publish, but they select the most important ones and they bring it to our feed as we could see it. Oh, that's weird. Yeah, that's better. So that's one part of improving the storytelling. As Chris also mentioned, one other thing we did into improving the fan engagement is that we launched a website earlier this year called Wie wint de koers, or Who Will Win the Race. And what we're doing is we're predicting the cycling race outcome. So what we did for that is we actually used publicly available data. Just if people know the Pro Cycling Stats website, it's a website where you can get all the information about previous races. Well, we used that data, and we actually looked at the last 30 years of data to build several AI models that predicts who will be in the future the winner of a specific race. What we do for that is we actually combine a lot of information on the one hand to predict the different relationships between cycling races. So to predict, for example, in order to be good at Tour of Flanders or to be good at Paris-Roubaix, it's not that important to be good at the Tour de France. But for example, I3-prijs, Harelbeke, or Omloop Nieuwsblad, these are really the key differentiator races. Well, this is one thing that the AI model picks up. And then on the other hand, we have a model that looks more at features such as the shape of the rider. So how good is he right now? What was his historical track record, and so on. We feed all of that into to the model, and then we predict for the future, for the season to come, for the next coming weeks, our top 5 for every race. Why is that interesting? Well, on the one hand, it's a toy example to show what AI can do, but it definitely also has the same potential as Stephen and Pieter already talked about on scouting and recruitment, but something that has not really happened yet at this scale in the cycling world. So you can easily do exactly the same thing, more in the youth divisions within cycling, to also detect people. We're also better than Michel Wuits. That's something I'm very proud of myself. So we actually did a competition with Michel for a few weeks, and our AI model was able to have a better prediction. A week later, they announced that he was not allowed to be a commentator later. But I don't think that really has had any causality there. So a little bit more information about the technical details of how this all works. So you can actually see an overall view of the different features. So the model actually detects automatically what are the most important features for every race. We do this for every individual race. So you can see this here for Liège-Bastogne-Liège or Luik-Bastogne-Luik. As you can see here, the most important ones that the model picks up are races such as the Amstel Gold Race, Flèche Wallonie, the Liège-Bastogne-Liège of last year, and so on. So not really that surprising results, but what is interesting is that the model really picks it up automatically, and that we actually get a really good performance. Our overall performance is that we, on average, predict out of top 5, we predict 3 out of those top 5 in reality, which is, I think, pretty okay. Our model also changes over time. So as new data comes in, someone gets injured or someone underperforms or overperforms at one of the previous races, the model also changes over time. And so all these examples are really examples of how you can improve fan engagement, how you can improve for the really cycling fans, how they experience the race. But the real value is, of course, as Stephen and Pieter already mentioned as well, in can we improve athletes as well in doing that? And that's actually what we've been doing the last 2 years, a bit more. We started actually with looking at, again, the same video pipeline that we have. Can we now use this video pipeline to make more strategic decisions within cycling race? So one thing you can see here is an overview of how in the women's cyclocross race, different, and it's for specific important segments through sand, different riders are actually taking different decisions in how they are going to approach that sand segment. And also over time, you can see it evolve as well. Something that we can automatically derive, and we can actually do anomaly detection to see who is, again, underperforming or overperforming in that case, and immediately also change or give the team the ability to change tactics if needed. So that's one example where we're doing this in cyclocross. We also did some work as a side story in hockey, where we did the same thing in terms of an entire AI-based pipeline to really automatically annotate events during hockey. So what you can see here is based on camera data, where we immediately detect what the X and Y positions of the players. The good thing about it is that we can do this with one single camera. That's the most important innovation we have here. So we're able to get a 3D image or a 3D position, 2D position out of a single camera. And we actually translate this into an entire dashboard for the national hockey team into how this in real time influences the play as well. So things such as how much pressure is a certain team putting on the ball, how much, what is the formation that the team or the opponent team is taking, especially for a game like hockey, which is pretty tactical as well. These are really important dashboards, which we are able to generate online as well. We also try to solve the most important question. We also try to solve the most important question, and that's having a pipeline as well, which automatically detects where the ball is. My video it doesn't show, but in hockey, that's one of the hardest parts. You have such a tiny ball, very hard to spot, but that was also doable. And we also apply this to cycling again, where we're now looking at can we actually detect all of this as how to see how bunch sprints are evolving. Because if you look at a bunch sprint, the way actually the last few hundred meters are evolving, it's a pretty tactical thing as well. We've been evaluating about hundreds of video footage of such bunch sprints, trying to find specific patterns into specific strategies in how a bunch sprint or how a lead out is being built up into cycling. This is work we're still doing, so we don't have any conclusive results on this as well. So this is really basically applying our old, I would say, our existing video footage machine learning pipeline onto more technical cases. And the last year, we've been looking more at the individual performance of a single athlete. And it actually started out of a few observations or a few conversations we had with professional teams. This is something more recent, where an anecdote of Thomas de Gent, who was actually performing really well in the last few months. And in September, he suddenly said, okay, I'm going to stop. He had very high power values, one of the best of the season at that moment in time. And suddenly he sent out a tweet and he sent out an email to his team, just saying, I'm completely fatigued. I have no possibility to continue anymore. My body is saying I should stop, while very on the contrary, I'm generating really high power values, but I just cannot go on anymore. And the weird thing is nobody really saw it coming. And this happens from time to time, where a rider is really generating really good performance, but for some reason, 2 days later, 3 days later, it just stops for him because he gets fatigued, completely bored out, completely out of the season. And then actually, the question is, can you do something about it? The problem is, it's hard at a cycling to really detect this. There are things like performance tests that some of you might know. Performance tests in cycling works as follows. You get on a bike, you do a very structured protocol where you start off with a very low load on your bike. Very accurately what's happening during your buildup of additional load to see how your performance is at that moment in time. It's being seen as a bit the gold standard of what you can do in terms of assessing a person's performance. But the problem with this is that it's very labor intensive. Labor intensive in the sense that it's very hard on the body, very strenuous on the body. And that's why cycling teams actually only do this like once, max twice per year. Why? It just simply does not fit into the training scheme at all. If you do this, you need to be recovered fully. So it means that you need to take at least 2 or 3 days rest. And you will also feel this the next 2 or 3 days as well. So it messes up your training scheme with an entire week. Something that, of course, a cyclist can definitely wants to miss. And that's why actually the issues or anecdotes or examples like Thomas de Gent really happen from time to time. It's very hard for a current team to actually assess what the current performance is of the rider. Because these gold standard tests are really good and they're being held in very concrete circumstances, but in reality, they can only do it once or twice per year. But on the other hand, if you look at what a cyclist generates, it's roughly about 500,000 raw data points per month, only if you look at the type of workouts that he's doing. So these are data points generating power, generating heart rates, resting heart rate could be there as well, speed could be there as well, but mainly power and heart rate is going to be the most important ones. So what we're doing the last few last few months as well, is looking at how we can use machine learning to get a better analysis of what's happening within the rider. There are already in cycling a lot of systems, a lot of tools to do some kind of analysis of your training. The most popular tool is called Training Peaks, has also a more advanced version called WKO5. And you get these type of charts as a result. What does these charts represent? They typically represent the amount of power you can sustain for a specific moment in time. So for a few seconds, a rider can typically generate about 1,000 or more watts. This is a semi-professional rider, not one in the professional teams. And a bit further on, he can generate, let's say, between 290 for a semi-professional and 360 watts for another one. And these are the typical power. It's called a power duration curve, and this is typical curves that people look at to assess the performance of how a rider is. But in reality, it really doesn't work that well. Why? Because for a number of reasons. On the one hand, it gives you typical dashboards, with dashboard metrics which are averaged across all riders. So whether you're now a sprinter or a climber or someone who is able to get a lot of training load or someone who needs a lot of rest from time to time as well, these dashboard metrics simply do not work at all. There's a second reason that it doesn't work. These are all workouts which are averaged over a very large time window. So they look at what was your current performance for over the last month. But as a result, they're not able to really detect and identify specific issues within a single workout. Within a single workout, there's a lot of data available, heart rate, power, and so on. And often you can already detect specific anomalies there, but it's simply not done right now. Or it's done manually, but it doesn't scale at all in a cycling team. And a third issue that we have is that it doesn't really have a predictive nature. So you don't really know if I give this type of training load to a specific cyclist, how will this actually result into better or worse performance. And especially in cycling, this is really important where cyclists are really peaking for specific events. So where it's very important to be top at the World Championship and maybe be a bit less at the Tour of Britain, just to give an example. So what we're doing together with two professional teams, on the one hand Jumbo-Visma, on the other hand Lotto Soudal, is we're building right now what we call an athlete performance indicator. And it's basically the same type of lactate test that you would do, but we do it purely based on data. So we purely look at the data that the riders are generating as they are doing their workouts, and we're trying to build some kind of virtual lactate test which should correlate well with the actual lactate test, with the goal to really replace that golden standard, so that you have one every week. It's never going to be as accurate as that golden standard of lactate testing, but at least it gives you a lot more insights for a coach to really work on. And in the second part, we're then also looking at, can we give this a predictive nature as well. Just to give you a little bit more information about how we're actually doing this without going into too much details, we're using something called causal machine learning, where we're trying to derive causal graphs out of a set of time series data. And the type of time series data that we're using is typically the information about the workouts the rider is doing, typically the power and heart rate value as well. And we're also using aspects where Steven also talked about, such as sleep, heart rate variability. These aspects are, if they are there, are taken into account as well. And what we generate is some kind of graph that says these type of parameters, these type of features will have a combined impact on you in the future as well. So really causal relationships from one side to the other. Just to give you an idea of where we are there at that moment, at this moment in time, we're actually building. We are able to build such a metric as well, and we're splitting this into two types of fitness. So people who know a little bit about exercise physiology, you have thresholds, lactate thresholds often called, one defining how good your aerobic fitness is, so how defining how long you can actually go on for a few hours in terms of power, and one focusing more on your anaerobic threshold, so saying what is the highest type of power you can generate, loosely speaking. What you can see here is a curve showing the aerobic fitness of a World Tour rider. I'm not going to tell you his name, but he's a World Tour rider from Jumbo-Visma, and he has the same first name as me, so you can probably guess a little bit. This is from his 2016 period, where he was really good at the Giro. And you can actually see this really in the data. So you see that his aerobic fitness is really high during the Giro period, but mainly also that his anaerobic fitness is really spiking during his Giro period. These are just lines on a graph, and anyone can draw these lines on a graph. Of course, you never know whether they're 100% correct or not. The only thing we can do is we can correlate this from time to time with those lactate tests that they're doing, only a few times per year, but we can do this for several teams. And what we're seeing is that we have an error of about 2 to 3 watts, which is really, really low on these specific moments. So all in all, this is the direction we're heading. We're trying to really focus on cycling right now as well, and where we're trying to help coaches, not replace coaches, but help coaches into making the right decisions. The reason we're doing this is because there's a lot of data available in these cycling teams. But as Steven also mentioned, often they're just not. It's just a dashboarding system. They're collected, but it's hard for coaches to really look into the data completely. And that's what we're trying to help out with them, so that they don't need to look always at the data, but that we can build some kind of early alarm system for them, warning them that they should need to have a closer look in the data and giving that predictive power to the system as well. So this was a bit of a rundown of several projects that we have in this domain. I'm very happy to answer some questions.
All right.
Sure. In terms of
So
time.
for the interest of time, let's again keep it at one question. So if somebody has a question.
So, anyone who wants to ask a question here? I cannot imagine that no one has a question. It's impossible. There we go.
On the who will win the race, you asked, I think, the match against DSLeuven. You only asked the winner, is that correct?
Well, it's a funny story. We did the top 5, and in terms of the winner, it was a tie. So in terms of the top 5, we won with a landslide. So the thing we did for 5 races. I think, if I imagine, he gave gave his top 5. We gave our top 5. And we were always able to predict more people in the top 5 than he had. There was on VRT News, they had a small video on it, and they only showcased the top 1 then, because it was a bit more exciting in terms of the story that AI had not won from the human yet. But in reality, we actually won. But
One final, or do we stop?
Yeah, let's one more. If there's one more. All right, and then our final speaker of today is Agata from Telenet. She will talk about TV viewing behavior and what you can learn from TV viewing behavior to get insights into soccer fans and fandom.
Yes.
Ja, thank you.
Yes. Does this work? Yes. Okay. Hi everyone. Thanks for being here tonight and bearing with us for the 4th talk of the day today already, and not, for example, sitting in front of Netflix and binging on the new season of Tiger King out since yesterday. So, welcome to not only football fans, and if you came here for only fans content, well, it's not this talk. So it's not only football fans. We will talk about some fans eventually, actually about the Belgian football fans. And I hope to let you in on some interesting insight potentially, and also Telenet data work. So my name is Agata Bak-Geerinck. I work for Telenet's entertainment department. So that's part of Telenet that deals with viewing sessions and digital television, as well as premium entertainment packs such as Play More, Play Sports, and streams. So unlike the fellow presenters, I'm not a data scientist. Rather, I like to see myself as a business-minded data analyst. So let's dive into this story. There aren't many of you here who actually know me, and the ones who know me, thanks for coming, and also to the guys on the YouTube. So, but actually this slide already reveals quite some hints about myself. Yes, I come from Mechelen. I love football, and I could not resist putting the picture of my favorite team here on the screen. And of course, the third part, telco, Telenet. Telco has way more to do with sports and also football than we might all think. Well, Telenet itself is not only supporting KV Mechelen, of course, and also the female Anderlecht team, but it's also keeping a keen eye on the world of Belgian sports. But maybe some of you also noticed that there's one more logo here, the Play Sports, probably one of the most complete premium entertainment packs on the market today, and also the subject of the presentation. But before this sounds like some kind of a sales pitch talk, I'm just going to stop here and ask you a question. How many of you actually ever go to a live football match at a beautiful stadium such as this one? Do you ever go to a football match? A lot of hands, myself included. So great to hear that. But of course, you know that you don't ever need to be at the stadium to call yourself a football fan, right? In fact, you don't even ever need to go to the stadium at all. You may follow all the matches, your favorite team and other teams, on the screen. So on the big screen or on the tablet, on the smartphone, on any device you might have. And then when you do so, you typically generate viewing data. And this viewing data will be collected, obtained, and in some cases also analyzed by your cable TV provider, in my case Telenet, or any other streaming service that you use. But before you let in that frown on your forehead and start thinking that the big sister is watching you, let me maybe explain a couple of things first. So at Telenet, we are really serious, of course, about data privacy. So we only analyze the data from the customers who actually allow us to do so, so who consent to it via a privacy setting. And analysts such as myself work with tokenized data. That means that we have access to hashed ID codes of set-top boxes and devices, and we cannot directly link it to a customer name or address. And analyses that you're about to see are typically a combination of raw data, which in this case are viewing sessions, what people are watching on the screen, enriched with master data, which we either directly collect from the client, being where he lives, what's his age, or which we derive ourselves via, for example, customer segmentation models. This ends up typical data work, of course, aggregations, some kind of tables, dashboards, and we arrive to analysis presentations, which we typically would use among our marketing departments for customer targeting and so on. Even sometimes we share those insights externally. Think about press releases, media campaigns, or even data talks such as this one. But let's come back to our supporters. Of course, I said that we have this Play Sports pack, but when you become a subscriber, we are never going to ask you a quite crucial question. Why? Why do you take this pack? But for us, it's actually very, very important to know if it's for golf, maybe it's for basketball, rugby, football. What's your favorite competition? What's your favorite team? It is, however, critical for us at Telenet to know that. Why do you take Play Sports? Of course, we want to provide as good product to our clients and cater to all their needs. But also, we need to understand what is the key trigger for people to take Play Sports. And we would use the viewing data to do just that. So based on viewing data, our data scientists would typically segmentize customers into groups. For example, based on their favorite sport and intensity of viewing, we would segment clients into categories such as tennis lovers, frequent hockey watchers, local football, foreign football lovers. So still quite, let's say, high-level groupings. There's also another use case where we would use the viewing data, and that's typically for the sport right negotiations. Of course, we would like to know that the sports people are watching are actually, are worth it. So we also don't want to suddenly disappoint a large group of clients if we stop broadcasting a sport that they might love. Think about a niche sport such as rugby. What if we decide one day to just stop broadcasting it and we get to know that clients churned just because they were really only in it for rugby? So this is critical for us. But out of all those sports that you can see here on the screen, which we all show on Play Sports, how much time you think actually is shown goes to football? So out of all the hours people spend in front of Play Sport channels, we have around 8 of them, how much time goes to football, you think? Anybody thinks it's around 50%? 75%? More than 75%? Okay, I think according to it, it's between 50-75%. Well, actually, it's as much as 80%. Yeah. So looking at the availability, more or less half of what we show on Play Sports is football, but 80% of actually what people are watching is football. So football is key. And here on the right side, you even see what are the main competitions. There is actually the biggest group of clients who take Play Sports only for the local football, so for Jupiler Pro League. There is also a big group of people who, next to our fantastic local league, also sometimes like to see Lukaku and De Bruyne score in Premier League. So that's understandable. But as you can see, that actually Jupiler Pro League already justifies quite big proportion of clients. So that's why we wanted to go one step deeper and not only know that we have clients who love football, but we wanted to know who are actually supporters of individual clubs. We analyzed around 500,000 customers of Play Sports across several years. And we wanted to know which football clubs have had the biggest groups of supporters. Obviously, we don't know that. Whom, right? You might watch several different matches. So we had to predict ourselves, or actually derive ourselves, for which club who supports. And we did it quite simply, of course. No fancy data model this time. This was just based on the time allocation on specific matches. So imagine that this is all a given customer has watched during the entire season. You probably already see something there. The results are highly fictive. Otherwise, KV Mechelen would already be a champion. So just looking at this, you can clearly see that this client spent most of his time to KV Mechelen matches. No, it's not my viewing behavior. Actually, except for one game between Anderlecht and Bruges, this client actually exclusively watched KV Mechelen. So based on this, it's quite easy to derive his top 1 club is KV Mechelen. This simple way, we derived top 1 club for all 500,000 clients of Play Sports. Now, we of course wanted to know, is our predicting accuracy correct? How can we now know that we are really identifying the clubs correctly? So we ran a small test internally at Telenet among our clients. We asked 20 volunteer colleagues who would like to actually get tested on their top 1 football club. So it turned out that we had the prediction accuracy of around 95%. That means that on 20 colleagues, 1 colleague did not agree with our verdict. Well, we predicted that his favorite club is Beerschot. The guy didn't agree. Well, we don't know if it's because he didn't want to admit, or maybe this was indeed a problem with the prediction. But what we found out is actually this. This is probably not surprising. You can clearly see which clubs have the most supporters across our clients. So basically, there are few clubs with the biggest groups of supporters. There are some mid-range clubs and long list of clubs with not so many supporters. I'm sorry for OHL Leuven. Maybe next year better. Why is it important for us? I mean, why would Telenet now care how many people support for Standard Antwerp or KV Mechelen? Well, we did not know that a couple of years ago. And a couple of years ago, maybe you remember KV Mechelen was at the range of degradation to the 2nd league. And back then, we also did not have the rights to broadcast the 2nd league matches. So we did not know that by not being able to broadcast matches of KV Mechelen, we will actually face huge churn of KV Mechelen supporters at the end of the season, when it became apparent that they will no longer be able to see KV games on Play Sports, they basically churned out of Play Sports, and many of them also took their entire connectivity bundle, think about TV cable, internet cable, and everything, and went to the purple competition. So, of course, this is not what we wanted. What happened is the breakneck speed negotiation to actually get those rights back. And as you see, end of March, we actually succeeded. And KV Mechelen was the only club from second league which we managed to broadcast again. Nowadays, the situation is easier. We also broadcast the matches from the second league, so we are safe. But should we know how many client support for whom, we would probably save quite some money and time back then. Second thing we wanted to know is social demo information about those supporters. Are they evenly spread, or are there clubs with, let's say, younger supporters, older supporters? Maybe some club has a lot of families among their supporters. You can imagine that this kind of information can be quite interesting for our, let's say, football partners. So we identified that actually the biggest clubs, Bruges, Anderlecht, and Standard, have a lot of supporters among meteors. It seems like when you're around 40, 50, it's safe to support for those clubs. When you're younger, it seems like you kind of dare to support for clubs which aren't all that super successful, have played both in first or second league in the couple of last years. And if you're a senior, it seems that statistically there will be more supporters for Gent and Genk, and especially Sint-Truiden. Now, the older you are, of course, also the more time you spend in front of television. We know already that there's a huge correlation between your age and time you were spent in front of TV. So we wanted to also check whether this, let's say, population of supporters can be visualized over here. You remember seniors watching a lot of STVV matches and also a lot of TV. Now big clubs such as Anderlecht, Bruges, and Standard typically score in the range of meteors, while, let's say, the clubs with quite versatile supporter group, even Gent and Genk, with a lot of statistically more seniors, still had some younger population. That's why they end up more or less around the average. And the clubs with youngest population be typically skewed to the left with less time, TV time per day. I guess nothing very exceptional here. We know the older you are, the more time you spend in front of television. So typical correlation between age and viewing. We went also one step further and thought, okay, but how about the geographic distribution? Now, do all Bruges clients, Bruges supporters live in Bruges, or are there also some Bruges supporters in Antwerp, and so on? What I'm about to show you are 6 maps of Belgium, and I think you know where I'm getting. If you hated geography at school, you will not like me today, but the goal is to guesstimate which football club I'm talking about. Probably a mental guess, and of course, it's not a difficult exercise. Just by color coding of supporters, we can very quickly identify what I'm talking about here. But there are also quite some hidden insights over here, and these are the ones that I would like to highlight. So we noticed that Bruges and Anderlecht have actually the least concentrated supporter base. Only 5% of Bruges supporters actually live in Bruges. This is not much. Of course, this can be explained by the huge potential of those football clubs, especially if I'm talking about Bruges, but also the fact that they collect quite some, let's say, supporters from little towns and villages which are far distance from bigger cities. No big surprise. Gent and Genk tend to gather a lot of supporters regionally, while Mechelen and Antwerp tend to have huge concentrations of supporters in the city itself. For us, this was a quite interesting insight. Now, you know that when you support for football, you also have a family, and often in a household, not everybody is a football fan. My husband hates football. So now we wanted to know what happens when those football supporters are no longer watching football. This could be me, by the way. Well, of course, this happens. Others take over. So football supporters, as I said, are not the only inhabitants in the household, and football is not the only thing on television. So we wanted to know if there are any statistical differences between how we consume the general television, if you support for Antwerp or for Bruges. are there big differences here? Can we find some significant, let's say, group of fans, maybe some FC de Kampioenen fans, some super fans of the mall? That was a little bit the goal. So what we've done, we went ahead with a few categories of probably the most tendacious shows we could find on the market. And we wanted to check whether for those shows which you see depicted on the screen, some supporters have significantly higher viewership than others. Maybe you already remember actually that there is a huge correlation between how old you are and how much time you spend in front of television. So this time we wanted to control for the age, and controlling for live stage, we were a bit disappointed because we did not find so many significant differences. But there was one show which actually did have significant differences controlled for the live stage. So one show had statistically way more supporters, viewers, than supporters from other team. The show I'm talking about is actually the Slimste Mens. Okay, maybe you're puzzled. So now that you know that there is a show that has statistically more supporters from one football club than other, you can get what my next question will be. Supporters of which club love Erik van Looy so much?
Antwerp.
Maybe. Let's have a quick puzzle round. So those of you who know football probably can guess immediately. I will just give you a few seconds. You know how it works, right? All right. Ready? Indeed, 10 points for the gentleman who guessed correctly. It's, of course, Antwerp. Maybe just very quickly for the correctness. The Golden Shoe, you know, the last winner, of course, of the Belgian Golden Shoe. The winners of the Crocky Cup, Bossel, Brian Priske being the trainer, the Danish guy. Rose tattoo of Raja Nainggolan, who now plays for Antwerp. And, of course, stam nummer 1, matriculation number 1 from Antwerp. But is it now all that surprising that Antwerp is supporting so much, not only for football, but also for Erik van Looy and his shows? Actually, not at all. We noticed that Antwerpenars really love everything Erik van Looy. They watch his movies, they watch his series, they watch his TV shows. Even the TV recommendations that he gives to Telenet clients have higher conversion rate among Antwerp. Again, this is not surprising. Erik van Looy comes from Antwerp. He comes from Deurne. So he's very, very popular among his Pappenheimers. But actually, we noticed that this is not a single case. Oops. Oh, we actually noticed that we Flemish like to watch local content. So this was quite of a shock effect for us, but actually this kind of analysis came back again and again. We found out that there's a huge correlation between where you live and what you like to watch. And shows which have quite some local connotations. Think about Gent West. The name is even in the name of the title. Very popular in Oost-Vlaanderen. Marina, the show about Rocco Granata, super popular in Limburg. Eigenkweek, West-Vlaanderen. Sturm der Liebe, probably language related. But the more we looked, the more we found out that indeed there is a huge effect of regional watching. So again, perhaps not that surprising at all that Erik van Looy is so popular in Antwerp. Probably it has actually nothing to do with football or supporters of the club. It just has to do with the fact that Antwerpenars just love local entertainment. So, just to conclude, I will very quickly go through the last slide to wrap it up. We noticed that there is quite some potential in viewing data into understanding how our customers behave, what are their preferences, and at Telenet we will be using this data where we can. For sport cases, we will typically use it for customer segmentation or also for the sport rights negotiations, as I've explained. Now, when it comes to whether you're a supporter of Antwerp, Bruges, Mechelen, or whatever, it seems that we aren't all that different in how we consume television, the general television. As I've explained, the biggest differences can be quite easily clarified by social, demo, and geographical profiles of those clients. So good news here, whatever your support, we are still quite similar in this case. So that wraps up my story and also the final story. So if there are any questions, I'm glad to answer. Thank you.
analyze the customers who give you permission to analyze? And what the percentage of customers give you permission?
So before the GDPR, this was, let's say, the default situation that you would have to opt out if you did not want that the viewing data is analyzed. After the GDPR, actually the situation is different. If you become our new customer, you per default become a customer who do not consent to that. So then we need to ask your opt-in. But currently, if you combine the situation pre and post, because we have, of course, a lot of clients who already are clients for many, many years, still over 75–80% of the clients consent to analyze their viewing data. It's very easy to opt out, by the way, and you're all free to do that. So, yeah. Any other questions? Yes.
Coming back on that question about people opting out. For example, because you're looking after streams as well, right? I don't get the kind of emails I get from Netflix from streams. Like saying, is that because people opt out a lot, that you can't do the same kind of, like Netflix sends out 2 times a week or every morning, we have a new show or a new movie you might like. I don't get it from streams, and I'm a streams client as well.
Then you must have opted out at some point, because I can assure you we do send it again. Probably very good recommendations. I suggest you don't.
Okay.
All right. Yeah. Maybe the last one. Yes.
If you look at the average fan base of teams in first division in Belgium, you also see that some teams were maybe over or underrepresented at Telenet. For example, a lot more Messi supporters, but maybe Charleroi supporters. They have a big fan base, but Proximus is a sponsor, so it's lower. Did you also find that?
That's total. Of course, we are only analyzing the customers who are having play sports. So that would be quite a big proportion of Flemish population. This is #1 sports pack in Vlaanderen, but that doesn't cover the whole country. I wish I could say that we cover whole country, perhaps in a couple of years. But today, indeed, this is more a situation we should call the presentation analysis of the Flemish football fans. So I fully agree with this statement.
One final, maybe?
There's, yeah.
For the shows that are more popular in certain regions, that you correct for certain marketing spend. So the kind of many, for example, Ghent West is marketed more in Ghent than other regions, or is that not the case?
No, actually, we do that correct because we don't ourselves do any marketing in that. So actually, whenever it's not a video on demand, which we produce ourselves or promote ourselves, such as, for example, via streams, this typically would be something that is broadcasted on TV channels where we, typically there's a catalog, the broadcasters get their fair share of TV shows. So in this case, we wouldn't correct for that. But that was also, let's say, a data experiment, data POC, but this kind of pattern kept on coming back.
All right. With that, thank you again, Agata. Yeah, and as I said in the beginning, so we didn't have to pay for the room. So thanks again, OHL, for providing the free room for us. And so now the bar is open if you want to have a drink. That's the way how you can compensate for getting the free room, I guess. Do, as a reminder, if you walk around, keep your mask on. And then if you have a seat or something, you want to take it off, that's fine. But if you're walking around, please put your mask on again. Thanks all for coming. Again, we'll see what we'll do in December, if you're going to do it physically or, again, virtually. We'll see a bit how the evaluation situation evolves with COVID. But thanks for coming. Thank you. Yeah. You don't take it home.
I really don't see it.
It's plugged in.
Streaming upset?
Yes. Thanks. And broadcast. Yes.